Hey guys, this section is 9.4. It's creatively called More Equations. And what it is equations that are in the form of a quadratic but maybe don't quite look at it first. And there's a couple of different approaches to this. One is the substitution, which works well in some places, and it's a really good technique. But there's kind of another way of looking at these problems that's maybe less confusing than a substitution, and so I'll show that for most of them. This first one, I want to get in this idea of substitution though. So if we look at this equation, there's kind of this repeating 5x plus 2 that seems to show up in a couple of spots. So I'm going to call that y. I'm just going to give it a little bit simpler name and substitute the y in just so I can get a better look at kind of what's going on. So this all is now y squared minus 9, this is a y, plus 18. So by doing that substitution, you can kind of see now that it's just a factoring problem. So I can go y minus 3, y minus 6 equals 0, as that was multiplied as 18 adds to be negative 9. So I get solutions of y equals 3 and y equals 6, except that I totally made up y, so now I have to unmake up y. So I'll come back over here, and I'll go 5x plus 2 in for the y equals 3, same thing on this side. And now I can just solve those. So bringing the 2 over, I get 1, and I got x to the 1/5. Here I'll bring the 2 over, and I get 4, and that'll be x to the, 4/5. So on this one, the substitution's kind of nice. It really does help you see it's a quadratic. Once you can see that though, the way this is going to work, because what I really did up here was that, I'm letting y stand in for 5x plus 2, so that means the y squared was the 5x plus 2 squared, which was over here. And so I could have thought of it as y and y squared. The thing in the middle is always how it's going to factor to. And so if you look at, when it's just plain y squared and y, we see y squared, we automatically split it to y. And we've never really focused much on the fact that that is the middle term here, is what we split it to. But that's going to turn out to be the case. So if this is 5x plus 2 quantity squared, then the plain version of that is 5x plus 2. So if I can see that this is like my y down here, then I can also, or I can just think of it as substituting this right back in at this stage. I can factor this by saying, okay, 5x plus 2, 5x plus 2, and then what multiplies to be 18 adds to be negative 9. So that's the same minus 3, minus 6. Cleaning this up now, I get minus 1 and 5x minus 4. And so you can see I'm getting to the exact same spot. 5x minus 1 equals 0. So I'll just go equals 1, and then x equals 1/5. 5x, I'll show it on this side, adding the 4 over. So same thing either way. This is going to turn out, once we kind of do a few more of these hopefully, this is going to turn out to be really nice for a few of the problems later in the section. It's just a lot easier way to look at it, at least in my opinion. Okay, for this next one I think I will do a substitution, and then some of the later questions I'll do that the other way. So this would be x minus 3. So then substituting I get 2y squared minus 7y plus 3 equals 0. And that helps me see it's a magic method problem. Or if you're good at doing them in your head, you can just do that too. 2 times 3 would make 6, so our numbers would be negative 1 and negative 6. So I got 2y minus 1, 2y minus 6 equals 0. And I'll divide out the extra 2 right there. So 2y minus 1 and y minus 3. So last time I solved all the way down. This time I'm going to show it a little bit different. I'm going to go ahead and take this right now and substitute it back in. I'm going to get a fraction here, so I'm just going to show you how to avoid the fractions. You could also come all the way down to the answers and plug this back in and solve with that step. But I'm just kind of trying to show you the different options. So here I'd have 2x minus 3 minus 1 And here I have x minus 3 minus 3. So this will be 2x minus 6 minus 1. This will be x minus 6 and 2x minus 7. I don't know that it's any easier, honestly. So once we're there, then we can just go x equals, bringing the 7 over, 7 halves, and x equals 6. Okay, I think this one I will do using this to factor because it has a 1 up front. So I'm going to go 2x plus 1. So it's just like writing down my x and my x that I would normally do. 2x plus 1. Then looking for two numbers to multiply to 10 and add to be 7. So that'll be a negative 2 and a negative 5. And then just cleaning this up a little bit, 2x minus 1, and this will be 2x minus 4. And then solving, 2x minus 1 equals 0, so 2x equals 1, x equals 1 half. And here, 2x, I'll just bring the 4 over right now, equals 4, and x equals 2. Okay, number 4 is another one of the magic ones, so I think I'll do a substitution. So I'm going to go 3 and then y squared minus 2y minus 8 equals 0. And we'll get this factored. So 3 times negative 8 would be negative 24. And so to add to negative 2, it looks like I need negative 6 and 4. So 3y minus 6 and 3y plus 4. Right there is where I'd want to divide out that extra 3, and I end up with y minus 2 and 3y plus 4. Again, to kind of avoid the fractions at the end, I'm going to put this back in right now for those y's. I could do it at the end. In the notes I did if you want to see that version. But this gets you a little bit easier math. And so be careful to get parentheses around that. And then this will be x, 3 minus 2 will be plus 1. And this will be 3x plus 9 plus 4. Or x plus 1, 3x plus 13. And then from there, x equals negative 1, x equals negative 13 thirds. For the rest of these, we could do a substitution, but I think it's easier to look at it as a straight factoring problem. So if I have x to the 4th here, naturally I would kind of think of splitting it up, x squared, which is the right thing to do because this x squared right here is actually kind of the tip-off that this is how it has to split. And I think it's easier just to solve these than the whole do a substitution thing. So we're looking for two numbers multiplied 21, add to be negative 4, so it sounds like negative 7 and positive 3 equals 0. And now I can just set each of these to 0. So x squared minus 7 equals 0, or x squared plus 3 equals 0. And then bringing this over, I can use the square root property. So x squared equals 7, I root both sides, and I have x equals plus or minus root 7. Over here I bring the 3 over, x squared equals negative 3, imaginary solutions are okay here. So I root both sides and I get x equals plus or minus root 3i. So what that means down here, for this is how they want the answers. So it says the two real solutions are plus or minus, so you don't have to type that. The real solutions are the one that doesn't have an I, so that your root 7 would go here. And the two imaginary solutions are, so that'd be your root 3 right there. This one we can factor by difference of squares. So I'll do 5x squared plus 3, 5x squared minus 3. And then from there, I'm going to just solve each of these equations. So 5x squared plus 3 equals 0. Moving this over, 5x squared equals negative 3. And then divide the 5 from both sides. And you're at x squared equals negative 3/5. So then I have a square, so I'll use a root to undo that. And so that's going to give me x equals plus or minus, this is negative, so there'd be an I, and then square root 3/5. On the computer, and also on the test, you don't have to rationalize it, but on the computer, don't rationalize it, don't do the root 5 thing. They have it programmed to take this version of the answer. And hopefully you can see over here, if I do all these same steps, this will just be positive, but I get all the same stuff. And I have it written out in the notes, but for the sake of time, this one's going to come out x plus or minus just 3/5, because there's no negative now. I'll do the plus. Okay, and these are two I would have you guys try. So this will go x squared, and then x squared, and multiplies to negative 60 and adds to be 4. Let's see, so how about, sorry, 10 and 6, had a moment there with it. So 10 and then negative 6. Let's see, setting those to 0, x squared plus 10 equals 0, x squared minus 6 equals 0. Kick the 10 over, and then root both sides. And I'll just write that with an I. So I do that and that. Same idea over here, add the 6 over. I'll root both sides. And x equals plus or minus root 6. And here's the matched difference of squares. So this will go 7x squared plus 2, 7x squared minus 2. And so if I do the positive root, 7x squared plus 2 equals 0. 7x squared equals negative 2. Divide the 7. X squared equals negative 2/7. And then I can apply roots. So this will be plus or minus I 2/7. Over here, I'll go ahead and show it this time. Add the 2. Divide the 7. Oops, drop my squared. And then I can do my root. And so we get the exact same thing, except without I. And again, don't rationalize for the computer homework. On the test, if I did this, I would take either answer just because of the ambiguity with the computer. Okay, and this last round of equations involves roots. We could do these the same way we did in the last chapter and isolate the root and square both sides. But the deal with these is that they are in the form of a quadratic. And another way of looking at this one is it's the same thing as x to the first minus 3x to the 1/2. So you can see if I square this, I get that. And here if I square the root, I get x to the first. So that is quadratic form. Instead of counting down 2, 1, it's counting down 1 and 1/2. All that aside, whatever's right here tells you how it's going to factor. So I would just set those up. That's how I think of it, because root x gets me back to that x. And then we need something that multiplies negative 10, adds to be negative 3. So minus 5 and a plus 2. So x minus 5 equals 0. Root x plus 2 equals 0. Kick the 5 over. Square root x equals 5. And now I have a root, so I square it to undo that. No ambiguity going this way, because a negative under here would have produced a 5i. So that'll be 25. Over on this side, though, I've got to be careful, because I'm getting that root equals a negative. And remember, square roots can never equal negative numbers. So it's not a D&E, it's just this branch doesn't produce a solution. So the only answer we have is over on this side. And this one is similar, but with a little bit more complicated root right here. But I'm still just going to, if I square this, I would get that. So it's in the form of quadratic. So I can just set it up like this. And then ask myself what multiplies to negative 12 and adds to be positive 4. So plus 6 and a minus 2. So this branch you can probably see plus 6 equals 0. As soon as I try to bring that over, it fails. So that's not going to give me anything. This side, though, x minus 2 minus 2 equals 0. So when I bring it over, it's positive, which is what I need. Then I can square both sides. X minus 2 equals 4, and finally kick the 2 over. And x equals 6. So this one, again, I'm just going to use that same trick. I'll split it into the roots. Instead of going x and x, I'm just going root x, root x. Then you need two numbers to multiply to negative 20 and add to be negative 1. So it sounds like a negative 5 and a positive 4. And these are the two I would have you guys try in class, by the way, sorry. So root x equals 5. Cool, square both sides. We get 25. And here I'm going to get root x equals negative 4, so no solution from that branch. And then with a little bit more complicated root. So square root x minus 3, square root x minus 3. So numbers that multiply to 20, add to be negative 9 will be minus 4, minus 5. And setting those to 0, and I'll just add the 4 and the 5 over. So 4, it's positive, so that works. Square it. And x minus 3 equals 16. And then add the 3 over. So this side gets us x equals 19. And here I'll add this 5. Root x minus 3 equals 5. Square both sides. X minus 3 equals 25. And notice nothing happens here because the square is just undoing that root. And then x equals 28. So on these ones, they can have no solutions, 2 solutions, 1 solution. Just depends on the signs in the quadratic piece.